Welcome to the video on Introduction to MOSFET. The family of FET is divided into junction field effect transistors. JFET is also available whose gate input is electrically insulated from the main current carrying channel and is therefore called an insulated gate field effect transistor IGFET. MOSFETs are nothing but IGFET. MOSFET is further classified as depletion mode MOSFET and enhancement mode MOSFET. These two MOSFETs are also available in P channel and N channel. The construction of DMOSFET, we are going to see the construction of N channel DMOSFET. For that, one P type of substrate is taken and on that two N type regions are created which are heavily doped, which forms the source terminal and drain terminals. These two N regions are internally connected with lightly doped N channel. So this is the channel between the source terminal and drain terminal. Over this, the SiO2 layer, which is acting as an insulating layer between the gate terminal and substrate and channel, is formed. Aluminum contacts are taken out from these two N regions to form the source and the drain terminal. Similarly, the aluminum contact is deposited to form the gate terminal, and from this P substrate another terminal is taken out, that is the substrate terminal. The symbol 4-terminal DMOSFET is represented like this and 3-terminal MOSFET is represented like this. This arrow indicates the N channel. For P channel, the direction of arrow is in opposite direction. Here, since the gate terminal and N channel, these are insulated, so that insulation or separation is represented by this gap in the symbol. Now the operation or working of DMOSFET. It is available in three parts. When VGS is equal to 0 volt, VGS some negative voltage and VGS some positive voltage. So first VGS is equal to 0 volt. When we apply VGS is equal to 0 volt, at that time we'll connect the gate and source terminals, or we short the gate and source terminals and will ground that terminal. Substrate terminal is also grounded. At the drain terminal, a positive VDD supply is connected. So this is the construction for VGS is equal to 0 volt. In this case, drain terminal is connected to the positive supply, so the electrons from this channel get attracted towards the drain terminal. Then they enter to the positive terminal of VDD supply. They come out from the negative terminal of the VDD supply and they travel like this, and again they enter to the channel through this source terminal. And since the electrons are flowing in this direction, the current is flowing in opposite direction, which is shown here. Now, as the electrons start flowing, the drain current also start flowing. Now, when we increase this VDD, more electrons get attracted towards the drain terminal. Hence, a depletion region gets created at this channel. So that depletion region is represented like this. And when we increase this VDD further, this depletion region also goes on increasing. At one balancing stage, the this channel width becomes very small, through which only fixed number of electrons can attract towards the drain, and hence the drain current remains constant, and it is denoted by IDSS, that is the drain to source current when gate and source are shorted. Next, when VGS some negative voltage. So when we apply a negative terminal of battery to the gate terminal and a positive terminal to the source terminal, here we are going to apply the VGS as a negative voltage, and then the source terminal and substrate terminal are grounded here. As usual, at the drain terminal will provide the positive VDD. When VGS is made negative, it attracts the positive charges in the channel and it repels the negative electrons from the channel. So in this diagram we can observe the positive holes gets attracted towards the gate terminal and electrons get repelled from the gate terminal. So when it happens, there is a recombination process of electrons and holes takes place near to this channel. But in this case, since the drain terminal is connected to the positive terminal and gate terminal is connected to the negative terminal, and due to this recombination of electrons and holes, number of electrons available for conduction, that number of electrons decreases, so that the maximum current we are getting in this case, means when VGS is equal to 0 volt, is less as compared to the VGS is equal to 0 volt. So since VGS is negative, here we can observe the depletion region gets created. As a positive VDD is increased, more number of electrons gets attracted towards the drain terminal and the depletion region also goes on increasing. At one stage, ID becomes constant. In this case, the constant level is below as compared to VGS is equal to 0 volt. As we made more VGS, means we increase this negative VGS, depletion region in the channel increases. Here we can observe that depletion region is increased, hence the drain current goes on decreasing. At one stage, the channel is completely blocked. This channel gets completely blocked and drain current ID becomes 0. This is called as pinch off of the channel. Next, here we can observe when VGS is equal to 0 volt, at that time we'll get the maximum IDSS current, but as we are going to increase the VGS in negative direction, the maximum stable current ID, that also goes on decreasing, and at one level that drain current becomes 0. Next, when VGS is equal to some positive voltage. So when VGS is positive, the battery positive terminal is connected to the gate and negative terminal to the source. Substrate is connected to the ground. Drain terminal is connected to the positive terminal of the battery, that is VDD. Here, since VGS is positive, negative charges are attracted inside the channel. So the minority carriers from this P substrate, here you can observe these electrons gets attracted towards the channel and the number of electrons available in this channel for the conduction, it goes on increasing. Since the number of electrons available for conduction increases, obviously the drain current also increases. So when VGS is having positive voltage, the maximum drain current we are getting, that is greater than IDSS. In this characteristics we can observe when VGS is equal to 0, we'll get the IDSS current, but as VGS we are increasing in a positive direction, the drain current is greater than IDSS. So MOSFET characteristics are divided into two characteristics, drain and source characteristics, which is formed against ID versus VDS, and second is transfer characteristics, which is minus VGS versus ID. So when VGS value is equal to 0, drain current value is maximum, that is IDSS, and as we are increasing this VGS in this negative direction, the drain current also goes on decreasing. This graph can be also calculated by this equation, ID is equal to IDSS into 1 minus VGS upon VP bracket square. This is the P channel MOSFET symbols for 4 terminal and 3 terminal. Here you can observe the direction of arrow is in opposite direction as compared to the N channel DMOSFET. Thank you. These are the characteristics of P channel DMOSFET. These are some references. Thank you for patiently listening this video.